Hello everyone and welcome back to PostNetwork Academy. I am Bindeshwar and in this session we will learn how to solve first order and first degree differential equations using simple examples. So without further delay, let's dive in. So first differential equation we have dy over dx, that is equals to e raised x. So we will use this method. Will separate dy to dx and thereafter we will integrate both sides. After integration we will get that would be y, and integration of ex would be ex, and one constant will get added, and this is the final solution. Let us see another equation here, and this is also there is also initial value problem is given. That means when when x is 0, so the value of y would be -1. That means here -1 when x is 0. Basically y is a function of x. That's why we are writing. So first of all, here we will write, or you can say that we will divide this equation by 1 plus x square into by 1 upon 1 plus y square. So we will get this one. And what will we do? We will integrate. So the integration of 1 plus 1 upon 1 plus x square, that would be tan inverse x, and the same way that would be tan inverse y. And here you can see that condition is given. So we will put this condition. So when here x is 0, so that would be y would be -1. So here what will happen? Tan inverse 0, that is again 0, and that is you can say that tan inverse -1, that would be minus pi upon 4. So we'll get this one. That means at the place of c we'll keep this one, and we'll get this solution, and there would be no constant. This is for what boundary conditions are there. So we will get the solution without any constant. Now let us see another initial value problem. So differential equation is given here. So let's solve it further. So here what will happen? You will separate y terms in the left side and x terms into right side. Thereafter, if we integrate both sides, so we will get this one in the left side and right side, and one more constant, and the value of constant we will get after applying boundary condition. So let us see. So when we apply it here, so finally we will get the value of c here 3. The value of c we will get 3. Now final solution we will have y square minus 2y is equal to x cube plus 2x square plus 2x, and the value of c we have got 3. Now when we solve this equation, that means we put in the left side y and right side this one. So that would be the solution. and when we apply initial condition, so we will get the value of y, that is minus 1, and the solution would be here. Now we will check domain of validity because it is in under root. So we should check that whether the value of x cause this expression in negative. So if we take minus 3 minus 4, so the expression under root that will be negative. So that values we cannot take because that will become complex value or complex number. So domain is valid when x is greater than minus 2. Now let us see another kind of differential equation, that is homogeneous differential equation, you can say that. So we will see that what is a homogeneous function. So a real valued function h of two variables x and y is called homogeneous if in degree n, if hx lambda y, when you will get, you can take lambda out, so that power would be n, it may be 1 2 3, so if 2, so 2 degree of homogeneous function. So this kind of equation, differential equation, we will solve. So let us see that one differential equation is given here, 2y square plus 3xy upon x square. Now that equation is homogeneous of degree 0 and we will put like this one. So in these kind of equations we will put v is equal to y upon x or y is equal to vx. So see that what will we get? We will get dy over dx is equal to v plus x dy over dx. Thereafter we will substitute in the equation. So we will get the following equation. Thereafter dv over dx. Thereafter we will separate v terms in dv side and x term in dx side. So now we will integrate. After integrating, we will get in the left side we will get log v minus log v plus 1, right? Because we know that integration of 1 upon x dx is log x. So the same pattern we are following, the same formula we are using here, and in the right side we will get log cx square. So we will get v upon v plus 1 is equal to cx square. We will plug the way again, we will put the value v as y upon x. Finally we will get the solution y is equal to cx cube 1 minus cx square, and there is no boundary condition, so we cannot get the value of c. So that is the solution having a constant. Let us see another differential equation. Again it is homogeneous and we will plug y is equal to vx, and thereafter the same way we will get dy over dx is equal to v plus dx dv upon dx. So plug the value, you will get this equation. There is no y, only v and x, and this way we can separate, and after separation we will integrate it, and this side will get log and this side minus 1 upon 2v square, and where c is constant. Now what will we do? We will put the value of v, because we have substituted, so we have to write the value of v or plug the value of v, substitute or replace, you can say that. So when we replace it, so final we will get the solution y square is equal to x minus x square upon 2 1 upon log x into c. And because we don't have boundary condition, so we will not have solution without constant. Now another differential equation given is here. So again the same way we will solve, we will put here different way. Here we will put x is equal to vy. We can also use this expression. There is little bit different, you can see there. So this will also work and we will plug these values. So we will get this one. We will get an equation in terms of v and y. So thereafter we will have this one. Thereafter we will separate it. Not in two terms. Here v terms are here and y. Right? And here c. So when we integrate, we will get this one. Now what will we do? We will replace v by yx. So let us see. We will get yx. So when we plug it, we will get this one. So final solution would be this one. There is no boundary condition, so again we will have solution with a constant. So hope you understood. For more videos and resources, you can visit PostNetwork website www.postnetwork.co, YouTube channel, Facebook page, LinkedIn page, and you can also visit GitHub repository for a code. So hope you have understood. Thanks for watching the video.